Okay, we have the critical angle here for the glass block as 42 degrees Celsius. So we just have to be mindful if the angle of incidence is more than 42 degrees. That means it's going to undergo total internal reflection if the ray is traveling from an optically denser to a less dense medium. Okay, now let's look at the options. Okay, if the angle here is 40, we extend this to normal. This will be 90 degrees and this has to be 50 degrees. Okay, so now we know that the angle of incidence at this junction here, right, is 50 degrees. Is more than the critical angle. So we are expecting to see total internal reflection. Okay, so A and B are out. Okay, so now we know that C and D are correct, and if this is 50 degrees, okay, this will be 50 degrees, and we can extend this. Okay, this will be 40 degrees. Okay, so now we have another reflection here. So it's moving from glass to air. Okay, from glass to air, you are moving from an optically denser to a less dense medium. You should see that the ray should bend away from the normal. So this one bends away, this one bends towards. So D is wrong and C is the correct answer. Okay, this is a question on the magnification of the image. Okay, so to find the magnification, we can just take the size of image divided by the size of object. Okay, so we know that every 5 square, 1, 2, 3, 4, 5 is 1 cm. So looking at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the size of the image should be 9 times 0.2. Okay, because 5 square is 1 cm, 1 square will be 0.2 cm. Okay, then after that we look at the object. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it will be 15 times 0.2. So we cancel this 0.2. We are left with 9 over 15, and we'll get 0.6. So the answer should be A. We can use a diagram here to illustrate this question. We have a boy here. So every time he hears an echo, the sound wave would have traveled 40 meters. Okay, so the distance traveled by the sound wave, okay, because the boy heard the echo 50 times. That means the sound wave would have traveled a total distance of 40 times 2 times 50 times. And the time taken for the sound wave to travel this distance is 12 seconds. So in this case, we use the DST formula. Speed is equal to distance divided by time. It should be 40 times 2 times 50 divided by the time taken. It will be 12. So the answer should be C. Okay, first of all, we have to understand that a magnetic material will attract a magnet. So it's very obvious here. Only option D talks about magnet, okay, because a compass needle is a magnet. So when you place the magnetic material near to the compass, it will attract, both will attract, so it will affect the direction in which the compass needle points. Answer D. Okay, we need to understand that the iron is a soft magnetic material and steel is a hard magnetic material. So let's recap the difference. A soft magnetic material, right, is easy to magnetize and easy to demagnetize. For steel, it is difficult to magnetize and it's difficult to demagnetize. Okay, so when the supply is being switched on, right? Iron being a soft magnetic material will be magnetized easier and faster. So the magnetic field produced by iron should be stronger. Okay, then after the supply is being switched off, iron being a soft magnetic material, it will lose its magnetism immediately because it's very easy to demagnetize. Whereas steel being a hard magnetic material, it is difficult to demagnetize, so it will still retain some of its magnetism. So after the supply is being switched off, right, the field produced by the steel will be stronger. Answer: